In this YouTube, I'm going to cover descriptive statistics and as part of that creating histograms and looking at normality. And this covers this covers number 2 and number 3 in the handout that was distributed on February 20th. It will be referring to this PowerPoint, of which I've got a slide up right here, and the PowerPoint is Statistics February 13th, 2018. So we'll be covering this idea of frequencies, measures of central tendency, and a few of these statistics that help us understand the variation across this data set. And this is for continuous data. So remember, we have categorical data, that data in those categories, which includes categories like strongly agree, strongly disagree, in addition to these you see up here. But we'll be doing this for a continuous variable, specifically body temperature and heart rate from the data set that you'll be opening as part of this, which is temp, sex, heart rate, the categorical version. So let's start by opening your data set, and the instructions pertain to the analysis that you'll be doing. The one I'm showing in this YouTube video is streamlining number 1 and number 2, and we start by analyzing these descriptive statistics, and we're going to choose frequencies and the two variables, the two continuous variables that I just mentioned. And then when we look at statistics, the ones that are requested in item number 3 were these measures of central tendency, which are mean, median, and mode. Looking at that range, so the lowest value and the highest value for that given variable. Also, the standard deviation, which is a typical measure of variance. We have other measures of variance that we can choose, but standard deviation is used most often and reported most often in research papers. And we're also going to look at skewness and kurtosis, and that has to do with the shape, and that'll be more clear in a few minutes. So click on these statistics that you want generated for your two variables, click continue, and then we are going to not display frequency tables because there's lots of different variables, and instead we will request a histogram, and that was from item number 2 in your handout. And so you request that histogram and you want to show that normal curve. Again, we click continue, and now we click OK. So here you see the results. The mean is simply the average of body temperature and the average of heart rate. The median is that middle value. So if we'd order all those values from low to high, the middle value is the median. The mode is the most frequent variable. So the most frequent temperature was 98 degrees, and there were multiple modes. So they showed the smallest mode, which was number 73, but they had more than one. The standard deviation is a measure of variance. So if you looked at the lowest and the highest and that distribution, did you have a lot of variance across those values or a small amount of variance? And you see that there was a lot more variance for heart rate than there was for body temperature. You just look at the size of those numbers. And 7 is a lot larger than 0.7. We'll talk about skewness and kurtosis later. And down here, we're seeing simply the lowest temperature in our data set and the highest temperature. The lowest heart rate and the highest heart rate. All right, so now let's take a look at body temperature. And this is the histogram. And this shows you that distribution of those values from low to high. And it shows you that curve, which is a little bit to the left. It's not straight in the middle. But if you look at it, it's pretty close to what we call a classic bell curve, with most of the values in the middle. And as we get closer to the end, there's fewer and fewer values at those extremes. Same for heart rate, although this time we see the bump is that this curve is a little more to the right. So we see a slight difference in that curve. So now let's take a look at the PowerPoint. I think I can advance this. And now we'll take a look at that idea of the frequency histogram. So here we're seeing a histogram for a different variable, for an age variable. And now we get to these terms of skewness and kurtosis. Skewness measures whether that bump is to the left or to the right, and kurtosis measures how peaked that bump is. Is that bump in the middle more flat, or is it more peaked? So let's take another look at a little more information about skewness and kurtosis. And we have these values of 1 and 2, or -1 and -2. And so for skewness, if it's a 1, it means there's, they call it a right skewness. But you have to look at the idea that right isn't where the bump is. It's a little counterintuitive. They're not looking at where the bump is. They're looking at where the tail is longer. So if it's right skewed, you've got a longer tail on the right. If it's left skewed, you have a longer tail on the left. And there's degrees of skewness. So moderate skewness is 1, extreme skewness is 2, either 1 or -1 or 2 or -2. For kurtosis, we're now looking at the shape of that bump. If it's flatter, I think that's the easiest one to detect. It's just more squashed. And we see that then that gets a negative value if it's more squashed. And if it's really peaked, kind of extremely peaked, then it has positive values. And for a normal distribution, kurtosis is somewhere between 1 and -1 if it's moderate, or between +2 and -2 when we think about extreme values. So we can go back to these results here that we have. We want to go to the output file, and we have those calculated values right up here. So we have a skewness. Let's see what this is for. This is for body temperature. And we are in that normal range of skewness. We don't have anything larger or smaller than a 1 or -1, and same with kurtosis. But here we see that difference. Remember, one was more to the right, and one was more, and now according to this, they're both slightly left skewed, which means a longer tail on this side. So I guess I was not interpreting those bumps very accurately when I talked about that earlier. But here when we look at kurtosis, we see that one is negative, one is more squashed, and one is a little more peaked. But once again, they're both within this normal. So body temperature was a little more peaked, and this one was a little more squashed. And we can definitely see that. It's definitely flatter here. So that's why we have that negative number. And it's definitely a little more peaked up here, but still within the norm. Standard deviation just talks about that idea of how much variance that was. And I think that's a little harder to see in a graph. So that's not something that you can necessarily see in your histogram. So as a result of this analysis, we could conclude that both of these variables meet the condition of being normal based on looking at this curve, but most importantly, by looking at these measures of normality that are diagnosed by this idea, by these analyses for skewness and the analysis for kurtosis.